Hello everyone, welcome to my YouTube channel. I'm Chukus. Yeah, I'm Chukus. I'm a developer. You don't need to know anything else about me. Bam. So today we'll be learning about Ton blockchain. Ton blockchain is nice and it's just built upon Telegram ecosystem, and it really has some nice features compared to other blockchains like Solana and Ethereum. Yes, every other blockchain claim they use little to no gas fees, but trust me, Ton really took that serious. They use at most like $0.01 mostly on gas fees, and depending on how you create your smart contract, you know, even deployments are now cheap, like deployments of smart contracts, like sub smart contracts, subject zones. I'll be explaining that. It might be unclear to you what I meant. It's not like just a normal deployment. The normal deployment is also cheap, like 0.1 ton. But besides that, everything is great and just nice. So into the class. So class one. So about ton in ton blockchain, you get this architecture of multi-tenancy, such a way that you could have one main contract that births many contracts, many subcontracts, to say it that way, so it's quite understandable. So for example, a good example is a wallet. It's a wallet contract. Now, the question you would ask when building a contract for a wallet type of thing is, who is an administrator and how can you host one to n to the power of infinity amount of wallets? So if I have a wallet and another person has a wallet, how do we keep everything together? How do we control them? How do we make sure there's no security vulnerabilities and all these things? How is money transferred, updated, this and that? And on something like Solana, you create a master contract where you then store the either the what's it called? It's not ABI. The contract address thing, I've forgotten what it's called. So, but there's this thing where you initialize a contract, a address inside a Solana contract, and then save it into like a map. So you have like this list of addresses, this list of maps, on Solana. I like it because it keeps everything together. But on Ton, yeah, it's a scenario where you have a master contract. Imagine me, like a class, like a JavaScript class, and then I have children that inherit things a little bit from me, but they are very, very as much independent as they can. The access I have to them is using my parent address, probably like my name, and their initialization properties. So an example would be you create a return master, a wallet master. Inside the wallet master, you can deploy children wallets. Now, if the wallet is to be initialized, I'll use my contract address and then their initialization properties. So for example, it might be the user's mnemonic phrase converted into a secret key or a private key and then sent to my own smart contract. So your contract may be AWQRZ something. The secret key might be some rubbish phrase. So that rubbish phrase combined with my own in contract address and some parameters are defined in the contract while deploying this children wallet would create a unique wallet. And trust me, it will never be the same. So you can't have conflict. So now if I have a billion subcontract a billion wallet using my wallet provider. Probably just imagine I am Telegram wallet or I am my Ton wallet. I'm Ton keeper. If I want to call your own, if I need something from your wallet, I just go into the parent contract and master contract. I get your mnemonic, your secret key, combine it, and I will always derive your own wallet. Now, you see the thing about Ton is you get independence. Except I define the controls in the parent contract beforehand. I can't go on messing with your own contract. The contract is as independent as it is. The owner of that subcontract is not me. Is your own address. Is the address you own, or is your own address attached to your mnemonic phrase? You understand? It's not my own. So that makes it a little bit independent, so it's a certain extent. I can send internal messages though. It's like internal DMs. The internal messages cannot be sent directly to that contract. But as a parent, for example, suspend account. You don't want anybody sending suspend account, but I can send an internal message to that contract through the parent wallet or through the parent contract. So when that is done, if I want to do something to that parent contract, to the child contract, for example, I get your secret key, I get my own in-parent parameters and all, and then create an instance inside the parent contract. In there is when I'll be able to send an internal message. So I'm not even directly messing with your thing in your children contract. I'm just sending an internal message. Now the internal message goes, reads, understands, operates. If there is a problem, this is beauty. You can send a bounce. So if something happens, money is missing along the way, you don't really get in turn because it bounces. So what they do is when a transaction is going, states are changing. It doesn't really change immediately. It changes, but it's sort of suspended like a transaction. If anything fails, trust me, it's reverting everything, sending your money back. Then like a lot of times in development, you just see so much cashback. Now talking about cashback, so there's this thing when you send a transaction on Ton. There's a tool for cashback. So yes, transaction on the blockchain will obviously use gas fees. You can orchestrate it in such a way that the person sending the transaction to the contract is paying. You can orchestrate it that the contract is paying. You can send it that the sendee, that's the person you're sending to, is the one covering all the fees. Yeah, Ton is beautiful. Now, assuming I send 1 Ton for transaction, just an example, and the transaction just is 0.0003 Ton to process everything, what happens to the money? On other blockchains, your money would end up in that side, in whatever account it stops. That's one thing. But on Ton, you activate cashbacks. You can put cashbacks, so the money gets reverted back. The change gets reverted back to who sends that particular message. Now, if change is returned back to me, right, from a child, and I have another parent, or someone called my contract, like someone called my operation to send something to the child. If I have a cashback on that particular operation to send something to the child, for example, deposit, if I have a cashback attached to me, I will send the change from receiving the change back to who sent it to me. So really, Ton is really nice. It's fast. The only downside of Ton is that there's little to no documentation now as we speak. This is August 2025. The documentation is there, but it really takes a lot of time to understand some key things. Compared to Solana, when you send a message, when you send a transaction of Solana blockchain, you get to wait, like literally wait in the front end, or wherever you're calling it, like a synchronous function, and then you get a response. which you can like send comments. Like you can put things for the console to see in the front end. Okay, this one went wrong. You can, through the contract, you can write logs in the contract that would reflect whenever things happen. But you see, tone is annoying in this way, because even I read like a blog post on Medium, and I don't still understand. Like it's a lot to take in. You really need to rely on things like polling and using Ton API, which is a bit expensive. If the free tier usually get blocked, rate limited if you are not paying. And there's Tonlight. I speaking right now. I don't understand much about it, but that's that one. When you send a transaction, you don't get an immediate response. You can either one do sequence number. So, for example, if I have a sub wallet, it's your Ton wallet. When I send the transaction to you, you increment the sequence number. So, in the beginning of the transaction, sequence number is like 1 or 2 or 5, for example. 5 transactions already occurred. So 5, let's use 4. So 4. And then I start pulling with a while loop. Keep on checking. What sequence number? Once sequence number turns to 5, a transaction has happened. The transaction was successful. And then I now check. Okay, let's say it was a deposit. Was the deposit successful? If it's so, nice. Deposit successful, amount change. That's one. There's this way where you can like do some transaction, because when you send a transaction, Ton will not give you your transaction. What's it? They won't give you a on-chain transaction reference. It might be like a transaction hash or address or a transaction, something like that you get on Solana and all those guys. You get it. If you want to do it, I don't even think you can do it on the server side. You can only do it on client as on browsers, where you get a hash, and the hash that they even give you is not the full hash. It's like a pre-calculated hash. So then you have to send that hash to the Ton transaction list pool, like a list of all the transactions. That API, you query it against your own contract address. Then it would most times return like the first 10, first 20 based off what you want transactions. Then inside those, you now have to filter through and get your own particular hash. Then you now get the transaction ID, and then you take that transaction ID back to find the transaction and check the transaction status to see if it's successful. Trust me, it sounds easy. I've not figured it out. How I do my own transaction is I pull like a thief. In my contract, I made getters, so they are getters. So there are things that you can use to get the states. Compared to Solana, where you have to like call the old API and then get that contract information once. You can call just little fragments of your contract, and you would, what is it? It's called getters. I really don't want to explain this anymore. But basically, it's like a function. Okay, yeah. So if you have a class, you can create a public function inside the class, like a public part of the whole private. If the whole class is private, you can make a little part function public that you can then call outside when you instantiate or initialize the class. So for example, if you have a class of car, you can have a getter called get color, but you can have a private information might be like get owner, so it will not be a getter. You understand? So I have all these getters. So when I send a transaction, I'm calling the getters like, yo, as this thing change, I get the initial state and I keep on waiting. As it change, good. So turn execution is blazingly fast. If a transaction starts now and in the next 25 to 30 seconds it's not done, there's no change, that transaction failed. Trust me, there's no two way about it. It just what it is. It would, if you structure your smart contract in a way that you've accounted for every worst case scenario. Trust me, you have to. Then you know like everything. If this happens, this must happen. So if I'm checking transaction, if I'm pulling like a get like, okay, for example, I send money to a escrow account and two people send money. So I'm checking as user one deposit, as user two deposit, as user one deposit, as user two deposit. If the two of them are no, I'm also simultaneously checking did transaction bounce, checking that one. If transaction did bounce, then I'm going to the next one, try to confirm, and then do this one, and then get so many things. So you can really use pooling. It's stressful because you're trying to send transactions on the blockchain and you're trying to give reactiveness to the UI. I feel like that's the only problem to an ecosystem has. Aside everything, it really beats most ecosystem. Like that I've used, trust me, I've not used a lot. Just Ethereum and Solana. That's all. And I'm saying most. Really bold statements. All the ecosystems are fast. All the blockchains are fast. Yes, but Ton is sexy. Yes. Especially for the fact that it's like Telegram on, and how easy it is to put in Telegram mini apps and but you can't get updates on your UI easily, which is like a downer for developers, because when people are sending their money on blockchain, they want to know that their money is moving. You don't want them to be doubting or second guessing, like, oh, wait for 1 minute, your transaction is processing. 1 minute. 1 minute runs fast when your money is sent. Like, it runs so fast. 1 minute might not be over, but in your head you're like, oh yeah, but 1 minute for where's my money? So yeah, that's what I'll say about Ton. I don't know, my other videos are going to be like this. I'll probably start posting coding videos and advices. But it was really nice talking about Ton after spending like a week plus on it and just seeing everything through my head. I never planned to make this video, but here we are, and enjoy, guys. Yeah. Oh, the video not ended.